Now, as we have just discussed that specific heat capacity of liquids and solids can be figured out using calorimetry. Next topic we are going to talk about is the high specific heat capacity of water. You know how much it is? It is 4200 joules per kg per Kelvin. So this much amount of heat, it's very high value. This much amount of heat would be required to raise the temperature of 1 kg of water by 1 degree Celsius. So this is a very huge value. In fact, it is 5 times more than the value of specific heat capacity of sand. So due to its very high specific heat capacity, these are the following usages and applications of how we use water for temperature regulation and how nature uses for doing so. First of all, climate near seashore is moderate. See, as I just said you that a specific heat capacity of water is 5 times that of sand. So to increase the temperature of sand and of water of same amount by same degree Celsius, it would require 5 times more heat to increase the temperature of water than in sand. So that is why the temperature near seashore is always moderate. Second one, the hot water bottles are used for fermentation. See, water has very high specific heat capacity, and that is why due to which it keeps hot for a very long period of time. So if it is kept in water bottles, which is hot water bottle, so it can be used for fermentation very easily. Next thing, hot water is used as an effective coolant in cars, all the machineries, because when the water is regulated through pipes and other system across in and out from the machinery parts, which is getting heated continuously due to friction and other stuff which is working in the engine, it can cool down, it can bring down the temperature of the engine. So water is an effective coolant. Though we also have coolant, the specifically named coolant in the market, but if the coolant is not available, water is a very effective coolant. I'm not saying that you have to use water as a coolant, but if coolant is not available, then you can use water as a coolant, because due to its very high specific heat capacity, it can take out a lot of heat from the engine. Next, farmers fill their fields with water to protect crops from frost. To understand this concept, you will have to understand two more concepts. First of all, the concept of capillarity. Second, what happens to water volume when it freezes. Now, I'll tell you something, don't experiment it at your home. If you have heard or seen that if you fill a water up to brim, fill a water bottle up to brim, take two different cases, take a glass bottle and take a plastic bottle, fill them with up to brim by water and place them both in freezer. The bottle which is glass will burst. Why? Because water increases to 1/20th of its volume when it is frozen. So during freezing process, water increases to 1/20th of its volume. So that is why glass bottles does not have the property of elasticity, so that they can elongate across their edges and they can let water expand, but plastic bottles do so. So plastic bottles are kind of filled and they are kind of dish-shaped from their regular structure because of the filling or expansion of the water. That is why it burst. So that was the freezing thing. Second one is capillarity. When we light a candle, or in Hindi you say it called diya, the diya burns because of the process of capillarity. Now what capillarity is? Suppose the marker's tip, which is made up of densely packed cotton such sort of material, ink has to flow out of it. Okay. So if it is working on the phenomena of gravity, I'll be writing with marker like this and it will work. But if gravity is the factor responsible for the working, it should not work like this, but it will still work so. So the point is, the liquid is not coming out of the tip because of gravity, it is coming out of capillarity. Capillarity is the process of rise of liquid through very thin columns, any thin column. Let it be plastic, let it be air column of cotton wick, let it be the columns inside the plants, it can be anything. So usually water is taken from bottom pressure to lower upper pressure by the process of capillarity. Okay. Now farmers fill their fields with water to protect crops from frosting. See what happens is, suppose this is a crop, okay, and at places where very low temperature or where temperature falls below 0 degrees Celsius, something -10, -20 degrees Celsius, there the plants, such plants will have water in their body, and because the plant nourishes its other parts by supply of water and other minerals by the action of capillarity only. So there are very tiny veins throughout inside the stem, due to by which water rises up and it reaches the other parts of the plant. So now this is a stem which is filled with thousands of capillary tubes, which is again filled with water. So during freezing, what will happen? As I just told you, water is going to expand. So whenever water will freeze, it will burst the chamber, and after bursting, the crop will ultimately die out. So to protect that, this crop is filled up to this level by water. So what will happen? During the fall of temperature, the lower temperature, the temperature below sub-0 degrees Celsius is not going to reach to the main parts of the plant, and the water will not freeze and expand, and the crop will still remain alive. So this is the way which farmers from ancient times figure out that by this way crops can be protected from sub-0 temperatures. Next one is, all plants and animals have more than 50% of their content as water. Even human beings have 70% of their body content as water. Okay, so if not water, then liquid should be the term used. See, due to high specific heat capacity, the liquids, especially water, has to take a lot of heat to change its temperature, and that is why if I want to increase my temperature by 1 degree Celsius, I have to give a lot of heat to increase the temperature of the whole body by 1 degree Celsius, because there is huge water content inside me. That is why the body's temperature keeps at a constant level. It helps in getting regulated. This is the nature's practice in regulating body temperatures of plants and animals. So these are few applications where high specific heat capacity of water protects and saves a lot of things.